Okay, sorry about that, guys. I'm trying to manage all the controls here. Admitting some people trying to get back into the meeting. No, there's still more popping in. Okay. So regarding the refill point, it is currently looking at what length of sensor you're using, like what your total profile depth is, and assigning kind of a default percentage. So if you're using one of the older CropX sensors where you've got an 18-inch profile, or maybe you're even using the offset feature and you've reduced that to a 4 and 14, you're dealing with a much smaller profile, it will use a little bit lower percentage on that refill line, maybe somewhere in the range of 60-65%. With a very deep profile, in this case a 3-foot profile, that percentage is going to be more between 75 and 85%. So in this case, the auto set point had set its full point at near 18 inches and set a refill point at 15.76. Now, people always say, well, where should you set your refill point? Should I set it at a certain percentage? I would not go about asking the question quite like that. I would focus more on how many inches do we have between our full and our refill point. In other words, how many inches is my grower willing to use out of its profile before we want to trigger an irrigation? Because that's what the red line is it's a trigger. It's not when your crop is dead. It's not, well, that's the line I'm going to get to when my pivot breaks down for a week. That's the point at which you want to trigger your irrigation. That's how the system is built to do its recommendations properly. Is the refill line is your trigger point and when you want to apply irrigation. Did anything come in regarding any questions with how the auto set points are working?
No questions on the auto set points. We do have a few suggestions for probes to look at.
Cool. All right, I'll rock it through these other examples and pull those up in a bit. So this was a sensor where we've got quite a bit of history at this point. We've got 4 weeks under our belt. We've seen some larger irrigation and rainfall events that have moved our full point upward. We kind of had an optimal profile to begin with. It wasn't so bad. This was a little bit further south and they had gotten some rainfall earlier this spring. In other words, they were in a better situation than this sensor here. Make sure. Yep. So in this case, if I go back and look at my notes, well, that's an optimal. Well, let me find. Let's go with this one. There we go. Okay, so I listed that this profile is actually closer to refill. I'm noticing while I'm installing that it is drier than at least this other field that we've looked at already. So when I go and look at that graph, let's see how it's changed over time. So installed about the same period. So we've had about 4 weeks under our belt. We saw the auto set point doing its job. Not a lot of rainfall occurred. I think we just had some small events. But I went to manual mode at the 1st of June. And since then, we haven't gotten above that. I think I'm okay with where I've got my full point now. We had a large rainfall event yesterday, early morning, So that's what this is. I think we got about, I think it was 1.30 on this field. So here's another example of what that looks like. And currently I've got about 2.5 inches before my between my full and refill point. And this is in a clay loam soil. The coarser texture your soil is, likely the less water holding capacity you will have. So that number of inches you have between your full and your refill point will go down a bit. So if we were in a very sandy soil, which I'll pull up as one of my other examples here, the distance between my full and refill line will be less because we just don't have as much water in our bucket to work with. Okay, so here's another example, and I will pull up that sandy profile. I think that's the right one. Okay, so here we are. We've got a sensor, and notice how these numbers are a lot lower. So this is the same depth of profile. We've got a 3-foot profile, but now our numbers are closer to 7.5, compared to 16, 17, 18 on those on those other sensors we were looking at before. So we have a much sandier soil in this case, because we just don't have as much water in the profile to begin with. In this case, this was one of the last installs completed, and so we don't have as much history as far as irrigation or rain events. We still have the set point set on auto mode. I'm hoping that tomorrow night is our next chance for some rain. If we miss that, we'll likely trigger some irrigation. These are some late planted soybeans. So they're not in desperate need yet, but we probably don't want to go more than a couple of weeks without some water within that first 6 inches to keep those roots active.
Hey, Nick, question.
Yep.
Okay, on that, it might be good on that one before that you showed that. How did you come up with where you set the full point on June 1st?
Gotcha.
Just to give everybody an idea, maybe,
Okay, sure. So
without having the data going forward.
I was kind of going off of my notes that I had. So in this case, I had listed it that it was at refill. So I know that it's at least 1.5 inches, probably more like 2 inches below what its full point would have been at the time of install. So at the time of install, we had a total profile moisture of 16.2. I ended up setting the full point at 18.1. So kind of having the experience with this field and kind of knowing how the profiles work with these sensors, I mean, and how dry it was compared to other years I've installed sensors. I mean, I know that based on that profile that I observed, we're easily going to be able to hold at least 2 additional inches of water. So that's where I went. So I went from here and said, I know I can hold at least 2 more inches, and then listed it at 18.1. Did that help, Scott?
Yeah, I mean, I was just, I kind of figured that, but I thought for some of the people that weren't as experienced as you might question, well, how did you come up with that jump there?
Yep. Yeah, and I mean, you're never going to get that exactly right every single time. You know, we still have to observe what that full point's going to be. But another helpful way to determine where your full point should be is if you're working with a field that had a sensor in it in the past. In the past, I feel like we had reached go capacity. So if we go back and look at the 2022 install, we had a full point of 17.8. And not every, you're not going to end, it's not like, oh, well, it was 17.8, now it's 18. It just gives you a general idea of what to expect. People don't take that as it's going to be exactly the same every year. Your sensor is going to perform a little bit differently. You might be off by plus or minus an inch, maybe even a little more. But if you had that initial reading at the time of the install, I think was what, 16.1. And if I went back and said, okay, well, I've got a full point of 17.8, you know what, that must not be a full profile. I mean, that's a significant enough of a difference that we could say, yeah, we know we're not at full at 16.1 based off of our previous install and based off of the observation we took at the time of install. And I guess talking a little strategy, when we got into the first couple weeks of June, my recommendation to the growers we need to be building soil moisture in preparation for now, basically. So we did end up, kind of on an upward trend line or kind of a flat trend line for those first couple weeks. A lot of the other sensors, besides this one, we kind of were trending upward with the total profile moisture within the last 3 weeks in preparation to build some additional moisture at that second foot for this time of year when the corn really kicks it in high gear. Okay, so we were looking at that sandy profile. Just, I guess, note how much lower those numbers are, but either way, the auto set point's going to still behave in the same way. Essentially, it's set it at its highest point. It's kind of one of those things where the auto set point only knows what it knows. So until we get that event, it's not going to move up. In this case, I had listed my status as optimal on the install of this field. It did have some decent moisture, even though it was pretty sandy. So my guess is we're going to end up maybe a half inch or an inch above that 7.5 line that's already there. And if we go back and look at the install from 2022, here's our sandy spot, and we had a full point of 7.6. So everything's kind of fallen in line with where we're at. And I did not prepare for that. I mean, I'm going and looking at this live with you. Last example, this is a longer term install with one of the new sensors. What I think the cool thing we want to show here is how good crops really can be at using water. Can anybody guess what crop this is? This is in wheat. This is in winter wheat. So we've got freezing and thawing cycles. That's why the profile looks like we're getting a bunch of moisture, is because the moisture thawed out and we were able to identify it again. So if you see sensors deployed over the winter, that's what you'll see there. So you see the automatic set points moving up based on those events. But as we got through the spring, we added some decent water to the profile. But it's been a little tough sledding in the last 3 or 4 weeks for this crop. But I would assume it's going to do all right. There was enough subsoil moisture to kind of maintain it through these last couple weeks. I imagine they'll probably be harvesting this in the next 10 days. So there's a long-term look at how a full point can change over time.
Got a question in chat here regarding the basically what reasons would there be for the algorithms not to adjust the full point on the graph?
If you see a trend where the moisture goes up from a wetting event and then you see the moisture stay for an extended period of time, in other words, you start seeing crop water use after that, or maybe you just see the line go flat because the moisture is just staying there, maybe the crop's inactive. Did we hold that water? Yes. So our full point should go up. If we see a pattern where we see drainage right after the event and then a flattening out in crop water use, this is not our full point, at least based on that event. We did not hold this water. This excess water either ran off or drained, and our full point is actually here. So until an event like that occurs, the full point's not going to move. I don't know, Lloyd, if you could give maybe some other background, maybe it's a different irrigation type. I ran into some very interesting thought processes during a discussion with a grower that's using surface drip on some vines. And I'm not going to get into that because that's a completely different discussion in terms of how the wetting front works, where the sensor is compared to the emitters, and how that affects the auto set point. But there's definitely some exception that probably if you're using any kind of a drip system. Okay, I'm going to pull up the 2 examples from before. Give me a chance here to get logged into the user that has that system. So, Owen, this one's coming from you. Do you have any background on what you've been seeing so far?
I just unmuted here. Yes, so this is a field of my own. It's on sandy soil in southern Alberta, and you can see where I installed the sand. I installed it wet, and you can see how the profile goes down. I watered it twice with about ½ inch. You can see how it goes back up twice, and it keeps trending down. I keep probing the soil, and it's moist, but the reading keeps going down. And I've added 2 more ½ inch cycles over the last week, and it continues to go down. I have water ordered for Monday again. So that's about all I can tell you about that.
Okay. Yes, good background. This must be a pretty heavy soil.
No, it's not. It's quite light, quite sandy. I'm unsure of what I'm seeing. That's the reason I wanted to bring this up. I'm unsure of what I'm seeing in the field.
Actually, let me check your
The
account settings.
bottom of the probe, obviously, it's holding its soil down below.
Okay, can I have permission to switch to a volumetric water content scaling method instead of saturation?
Yes,
Sorry,
whatever you want.
okay. That's how my brain thinks, so I
switch
noticed
it
you had
back,
some
no
high
problem.
values here. That's why I asked if it was a heavy soil, because it fooled me for a second there, but there we go. Okay, that makes more sense. Okay, so install occurs June 1st. Auto set points seem to be doing their job. You currently had a distance between your full and refill point of 4.7 to 3.5. So just everybody's reference, we've got a V2 CropX sensor. So we've got an 18-inch profile. And so, that's one reason we're dealing with some smaller numbers here. We just don't have as much soil, so therefore we don't have as much total water in our profile. And over the course of the last couple of weeks here, you said you've been applying some irrigations. The sensor seems to be performing hardware-wise perfectly. And you said, Owen, that your irrigation amounts were about half an inch.
That's correct. You can see each one of those lips in the graph that goes up. Each one of those was an application. That's correct.
Okay. So the amount, so think agronomically here, where our first sensor is this, well, let me look it up here. This is canola, okay. So when those irrigations are occurring, not one of the things you're seeing is that with only ½ inch applied, you're not going to have a lot of infiltration occur 8 inches deep. Like, for example, if we go back and look at one of these other examples, and what percentage of the water is being absorbed within that top 6 inches of compared to the whole amount. Yeah, we could look at this one. It's not going to let me look at it because I just logged into your account. I was looking at a different user. But if you're applying a ½ inch of water and you've got soil that isn't already saturated or at its fill capacity within that top 6 inches, the majority of that water is going to be absorbed before it even hits that sensor. So one, that's why you probably see just small amounts of change. So in this case, we went from 3.73 to 4.85. That's about a 1/10 of an inch difference each of these irrigation events. Well, the majority of that was absorbed above that 8-inch sensor. Now, one thing that is something to think about for the future, when you go to install a sensor, what's new for 2023 is what we call the offset feature. If anybody thinks that it would make more sense to see that first sensor at 4 inches instead of 8, you can do that. You just don't put the sensor in all the way, and you select what your offset was at the time of install. So that's one thing to think about for the future. And then, so the one thing that we can be sure of is that
Can I still set that offset now? Because I did leave a 2 set offset. I don't think I set that when I installed it though. Is that still able to set now?
it broke up a little bit, but I think what you're asking is that you did leave it out of the ground
2 inches.
2 inches. So you would have to, so this is for anybody. So if you want a sensor to go from whatever its current sensor settings are to a different sensor setting, you would have to deactivate and reinstall the sensor, which can be done remotely. You can just use a QR code generator after you've deactivated the sensor to install it again with your mobile device. And then it will start reading again. But you have to choose the depth setting at the time of install. We won't be able to merge those data sets. That is something that we can do. If for some reason you ever had to swap a sensor because one failed, we can always merge the old and the new data sets so that you have continuous data. But in the case where you're going to change from one depth setting to another, we can't merge those data sets. So yes, you can go back and do that. You would just need to deactivate and reactivate by doing a new install.
Okay, thank you.
But the one thing we can be sure of is that this sensor is operating properly, and we are trending downward at the depth that this sensor is. The one thing you can be sure of is that regardless of what this percentage is, if this is going down, the moisture is going down. We are drier now than we were 10 days ago. There's really no ands, if, or buts about that.
Okay, I can trust the data.
Yeah. So just, in general, for anybody, looking at data like that, if you've got a sensor that's performing properly, and giving you, something that's not just totally crazy, it's telling us what's going on around it. Question is why. Okay, I'm going to pull up another example here. This is from you, Evan. If you want to give me some background while I pull it up. Evan, are you still on?
You just asked another question in there about what this telltale sign of a sensor that isn't working properly. So he's on. He might just not have his microphone on.
Okay.
Yeah, I'm here. Just this, the one I put in there was it was a customer install. I just had a question because the set points dropped quite a bit, and then they came back up quite a bit. I guess that was my question. Why did it drop and then come right back up again?
Okay. I think we've got a good answer for this one. Do you have kind of a rough gauge on what the texture is on this field?
I believe it's pretty heavy.
Yeah.
A lot of that ground over there is pretty heavy ground.
Mm-hmm. Okay. And I would imagine that on June 18th, you probably didn't have a 2.5 inch event. Probably less than that in Montana, or maybe
we've been having a lot of real heavy spotty rains. So it is he's been irrigating. So if he got a rain on top of that irrigation, that is a possibility.
Mm-hmm. Okay. I guess my answer would be I would be concerned a little bit about the soil contact around this top spiral, and that can occur when the soil was drier or on the drier side to begin with, and maybe the installer didn't. It's kind of a combination of maybe using a little more water. The drier it is, the more water you'll likely need to use to help soften things up, and the amount of down pressure applied to turn it in the ground. Essentially, you want to make sure you're not going to turn the spirals into an auger versus a screw. You want to screw it in the ground. You don't want to auger the ground out. So that's one thing to be wary of. I wonder, in this case, I might leave it alone, because if this event looks like it was pretty darn heavy, we'll probably tell more in the next couple days here if that sharp drainage occurs again. But it might have finally rained hard enough that it probably might have filled in what void was created at the time of install, or at least somewhat. But the reason that these set points are moving up and down so much is, it's like we said on the examples of trend lines, this water didn't permanently hold. So in this case, right here, the algorithm saying, we didn't really hold that water. I didn't use an inch of crop water use. Therefore, well, I guess I'll move my set point again. So, or I guess I should be circling this one because that's when the set point went down. Does that make sense? So we had a void in the soil that filled with water here, and then it kind of drained out again. And we had a sharp decline after the event of total profile moisture because air is dry and water is wet, but soil is somewhere in between.
Yep. Yeah, that kind of makes sense. I just, right there on top, right after it moved those set points, it kind of looks like it held that moisture a little bit and then it dropped again. So I just, right after June 12th there.
Yep, that's a good one. So yeah, I'd probably just leave it for now and see how that performs in the next couple of days.
Okay. Yeah, I guess that was my, my other question is, how do you, how can you tell when a sensor is not reading properly or working properly? What's a good telltale to watch for?
Something that makes absolutely no sense whatsoever. If this was, I don't know, Ben, what would be some good examples? This or this for days on end or for weeks on end, maybe.
Yeah, those would basically be it.
Okay.
I'll pull up another example. Tyler, this one's yours. Any background on that one? Tyler, can you unmute and give us some background info? Got it pulled up here. So here's the sensor they were looking at. Looks like it was only installed last week. Not a lot going on there. Everything looks okay. This is a cornfield. Our VWC values look reasonable. I guess, Tyler, I'm not sure what your question is. Rebecca, I'll take yours. Do you have any background info on that one? Rebecca, can you unmute?
Well, nobody wants to be the one that gets up in front of the class, do they, Nick?
Oh, man, they're the ones that sent me the message, so.
I just sent I think I sent a direct, this is Dr. McComb. I sent a direct message to the support regarding the moisture status pending for one of our probes.
Okay, so if you see on your overview that the status is pending, it's likely within the first couple days after install, and the auto set points take a couple days to set those initial points.
Yeah,
If you
we installed this one maybe like a year ago. It's a legacy from like last year.
Okay, let me get to that
Was he
one.
talking
Rebecca, anything else on this one?
Yeah, sorry, I missed most of it. I was in the bathroom. But basically, did you explain it all, Kyle? No. Okay, so this field, it is sandy, but it's like super rocky. We've reinstalled it twice. And he just watered on the 19th, 7/10 of an inch. And it barely showed. And obviously it's oscillating pretty bad.
Yeah, and I think you'll see that the more temperature changes you have. If that's what that oscillation is just and that looks bad because you've got such a small graph scale. Like if you look at the true number of inches you're moving, I mean it's what 10 to 1500s. I don't think there's anything wrong with the sensor in this case. Like you said, I think it's just a really coarse textured soil.
Should we be seeing more movement of water into the profile with 7/10 of an inch?
I would expect the same. I definitely understand why you're asking the question. I guess I would make sure that pivot's applying what it's supposed to. And yeah, I don't think there's anything else really. One thing I do too a lot for other folks is I'll get in and look at the Sergo soil types, and that's all in this field data section here. That's a new feature for 2023. So just FYI, you've got all these data layers you can just scroll through. It's pretty cool to be able to do that. So there was our imagery, there's our Sergo. Sergo is calling it just a sand, at least where the sensor is located. So yeah, it must be pretty coarse. I think the sensor's seeing what it's experiencing. There was a question, is the algorithm using the soil type we selected to install, or is the algorithm just looking at sensor readings to determine field capacity? So as I said before, it is watching the sum graph. It does not give a hoot about anything else. I don't care what Sergo says the soil is. I don't care what. And again, I think your question was in regards to what your soil type selection was in the notes. In this case, looks like Rebecca selected loamy sand on the install form. It's just a note. It does nothing other than put some text in that box. So it is watching the trend line of the sum graph to identify where field capacity is. Ben, yeah, I'll let you get back with Dr. McComb on the pending status. Crop type, just a note as well, or a sensor using this for water prediction. Lloyd's got a question regarding whether or not the crop type determines what this future sum graph prediction is. I believe the answer is yes, because it's taking basically taking into account when it was planted and what the crop coefficient would be to determine, I'm going to get this wrong, ETC, ET0. Scott may be able to help me out which one the actual ET of the crop is versus the atmospheric ET based on the crop stage. So the answer is yes, I believe, Lloyd, that the crop does determine what this would look like.
Jason Mallard, do you have one down there at UGA you want to talk about? Not to call you out, buddy, but I kind of got to.
I don't have anything in mind right this second to look at. We've been really getting hammered with rainfall recently, so we're pretty wet. So I'm actually standing in the field listening and watching, doing an install right this moment. So.
Man, what a guy. Separate topic. One of the things that I have really been using this week when navigating and trying to get recommendations out is the new navigation in the Fields tab. So most people have been used to using this overview and some of the filters on here. Try to transition some of that workload over. I'm going to log out and log back into my account. Try to transition some of that workflow over into the Fields tab for our future additions to this overview. So what do I mean by that is cool features are here. And I'm telling you, it's especially for a grower with a large amount of sensors. Watch what we can do here. Let's select a grower. We've got a whole bunch of sensors. Now, this sort feature, you utilize that and it shows you the fields sorted from driest to wettest, or wettest to driest, depending on if you like to sort it that way. But here we are, we're seeing our driest field, even all of the fields within the optimal category. We're seeing the lowest one first, all the way to the wettest field at the bottom of the list. I think that's pretty cool because guess what? Now I got to prioritize these fields first and the ones I should look at first. The mobile app does the same thing. So as soon as you click on the Fields tab, it should be sorted this way. Make sure to use the filters, especially if you're a dealer. Use these filters here to help, filter by grower, filter by the category. If you've got a bunch of fields that don't have sensors in them, I mean, they would show up here first because this is looking at all of the fields. But we can get rid of those fields that don't have sensors simply by selecting the ones that have a status, because of the ones that have sensors. You can also filter by crop type. If I only wanted to look at all the corn sensors, boom, there they are. There's the lowest, most important corn sensor to irrigate next is this field. And another filtering tool, if you have different types of sensors. So I've gone to the sensors tab now. I may want to look at only my rain gauges, and I want to see all, click on these and look at all of my rain data. Or maybe I only want to look at the fields that have a low signal, because I might want to go back there and raise the antenna. You can use all those same filter functions, not only on the Fields tab, but also on the Sensors tab. Sorry, one more thing, back on the Fields tab, another most recently added feature is the ability to switch these views. You have a card view, which will be the default, and that's kind of the view we're used to seeing. You also have a map view. Boom, there's all our fields. We zoom in far enough, we get a status color. But here's the newest one, table view. I'm going to filter back to the fields that just have sensors, and voila, there's our driest to wettest sort again. So I'm sorting by soil moisture status. If you're a dealer doing recommendations for growers, this is a cool way to start generating some mass recommendations pretty quickly. Because guess what? Here's all our driest ones, here's the middle, here's the wettest ones. Produce your recommendation on that. Anything else coming from the messages?
Yeah, we
General
got,
question here on installing two sensors in one field, what the best practice there is, whether to create two fields or just install two in one field. And just navigation, the graphs around that.
I don't think I have a recommendation one way or the other. I think it just depends on your preference. If you would like to see a separate line on this list for each sensor, draw different field boundaries. If you would like to
Yeah, I would say that even if you have two sensors in the same field, it's going to default to whichever one's in refill or closest to refill as the one it's going to show you for the moisture bar.
Yes, thank you. Very good point. It will always show the driest sensor as the default. In fact, yeah, let me go back to that list. It actually shows you here on this view there, leading sensor. And if I would have put my nickname in like I should have, I think it has the nickname here. I can't remember. So it would tell you which one is, and what it means by leading is that would be the drier of the two or three or four sensors. Yeah, so when I click on the field, the way that you would view the other sensor in your field is under your graphs, you can toggle between the two different sensors. And again, I need to go back and add the nicknames to these sensors to identify them, and they would look like this. See how I named these silt loam, and sand. Those are my nicknames for the 2022 season. There's kind of two different soil types in this field. I guess I prefer this version of having two sensors in the same field. But you can do it either way. Good question.
Okay, just can I add or add on to that a little bit? So come at the end of the season, when I want to send the report to the NRCS office, can I get a separate report for each probe doing it this way, or is it easier to create two different fields for each probe? Or
The season summary report, I believe, should contain all graphs and sensors within that field that you're running the report for.
Yeah, and the reports are done by field, not by sensor. It will include all sensor data, but it's not possible to separate them into separate reports.
Yeah, if you want them, yeah, you kind of make the decision at the time of install, what field you want to associate the sensor with, whether that's two different fields or the same.
Right. Looks like we have two new questions here. First one is, how do you convert percent BWC to percent field capacity?
I'll probably have to get a clarification on that one if you're available, John. I guess let me start by clarifying what VWC means. And maybe you're asking, how do we come up with these numbers? You know, how do we get 9.35? Volumetric water content is a measure of what percentage of the total volume around that sensor is water. In other words, if we take a jar of soil and we break down all of the components, what we're measuring is the water portion by volume. So if we took that jar of soil and broke down all of the things that make up its total volume, you would have the mineral matter, the organic matter, and the pore space. That pore space is either water or air. Most of the time, you'll see that mineral matter make up somewhere between 40 and 50%. Probably got an organic matter makeup of between 2 and 5%. And the rest of that pore space in a coarse textured soil, this one's kind of in between. We're looking at volumetric water content values between 20 and 40%. That's kind of a middle of the ground. The heavier soil, there's more water in heavier soil because there's more pore space. It has more water holding capacity. So those numbers will be higher. The coarse textured soil, those numbers will be lower because there's not as much water holding capacity. So how do we get this sum graph? We simply say, well, if all of my sensors are reading X%, we just say, okay, well, each of those sensors is, let's say for easy math in this example, let's say all of these sensors read exactly 50%. In this case, we have a 36-inch profile. How much total water do we have if 50% of our 36 inches of soil is water? We have exactly half of that. So in that case, we would have an 18-inch sum value. We have 18 inches of water in 3 feet because every single sensor is saying we have 50% volumetric water content. I don't know if that helped you out, John. Hopefully that does.
Then we have one last question here, and that is it suggested that a user install one sensor per soil type?
I mean, it's going to come down to the economics of likely the crop that you're dealing with and how much variation there is in the soil. And maybe the question too is, can you do anything about the variation that occurs? If you have a pivot, for example, that doesn't have the capability to put more water on in one part of the field versus another, if you have two sensors in the field, what are you going to schedule off of? What are you going to schedule your pivot off of if it can't do variable rate? The driest one. So many times, if you're talking about a grower that's got multiple sites, you're likely going to have more economic impact the more fields you can spread them on. However, if you have enough variation within a field and you can manage those areas differently, then that's when it makes sense to have more than one sensor in the field.
Hey, Nick, I got a question.
Mhm.
Where are we getting the weather data for on the weather tab? Because, so I was looking at that the other day and it shows that we are gonna have heavy rain for the next, 6 days, and we have no rain forecast.
We had recently switched to a different provider. I think, I mean, it's one of the main, whatever there is, like 2 or 3. Is it DTN now?
ETN.
Yeah.
Okay.
So
Just like I clicked on the weather forecast today and it says 81 and heavy rain. We have no rain in sight. And I just wondering if it was on a different, how it sets it up on the time. It's supposed to be for that field, correct?
yes, that's my understanding.
I was just curious to see, because I had a couple growers look at that and said, well, this is way off.
Gotcha. Like I just looked at this example. I can't say that this is wrong necessarily for this location. I know we've got some chances tomorrow, and you know, yeah. I don't know, something we could look into. Just send some
Okay.
screenshots and then we could double check things on the back. I haven't spent a lot of time looking at the weather.
I mean, I don't hardly look at that, but I just, like I said, I just had a couple guys ask and I wanted to just follow up on it.
Mm-hmm.
Yeah, when it comes to the weather, we know, especially with storms around this time of year, that we don't always get it across the whole front, where it can often be scattered pockets of individual cells where it'll hit some of your fields and then miss others completely.
That would probably be more on like the automated rain events that you're talking about, Ben, on automatically recorded rain events.
The feedback that I've always gotten from customers, because I've never really paid attention to the weather myself, honestly, but the feedback that I've gotten from most customers has been very, very complimentary of the fact the weather's lines up pretty good. So that's the first that I've ever heard what you're saying there, Scott, honestly.
Yeah, I mean, it seems like they all come from about 2 or 3 different places, no matter what platform you're on. But you basically have DTN, IBM, and like Terrace. Those are the 3 big ones, I think.
Yeah. Well, like today it says heavy rain. I mean, the temperature and that's pretty well right, but it has heavy rain. And I think the chance maybe 2%.
Mhm.
So, I mean, it's not a big deal. I was just had a couple guys ask.
Sure.
Are you gonna go over setting up the root zones? Or is that another time?
Good question. I hadn't planned on, I don't use them very much. So for those, what Scott is asking here is this feature to the right, which is called a root zone sum. That feature is used when you want to create a sum graph that is excluding a portion of your sensors. And that portion is determined by you. So you would set your depth. So in this case, let's say that we're going to set our depth to 18 inches. It's probably going to be about half of what our full point was before. I'm going to go with 4.5. This is kind of a trial and error type of thing because you're not quite sure what the sum graph or the profile, sorry, the root zone sum is going to look like until you create it.
Just an FYI, so in our neck of the woods, we have a lot of sandy soils, so we have like a lot of trouble holding more than 6-8 inches. So we have taught our guys to strictly irrigate mostly off of the root zone graphs, just because we can keep more water and keep them going better that way. Just our thing here.
Yep. Yeah, and that's totally fine. As far as the field's logic, see, now that I activated a root zone sum, that now becomes my primary driver for my soil moisture status and my status bars. So now if I went back and looked at, my fields list, it would be sorted according to this logic, not the profile sum. So as soon as you turn on a root zone sum, that becomes your primary driver for what your moisture status is. In this case, I'd probably go back and move the full point down a little bit, probably closer to 3.7 instead of 4.5. But so for those using large sensors on a small rooted crop, this is very important for you because if you are managing potatoes that have a maximum of a 16 to 18 inch root zone with a 36-inch sensor, it doesn't make a lot of sense to look at the moisture between 18 and 36 inches, right? So therefore, let's turn on the root zone sum and say, let's maximize, or let's, cut off and only look at the sensors between 0 and 18. So that's what this does. So back to that same math again that we talked about how to get from volumetric water content to a profile sum value. And it's just doing the same thing. It's just doing the same math. It's just not including the sensors below whatever depth set. If for some reason you ever wanted to cancel your root zone sum and go back to using a profile, you can just delete the set points here. So I went to my history and I'll just delete this and I'll be back to using my profile sum. I just need to refresh here. Okay, any other questions?
Nope, I think that covers all the
Um,
questions.
Nick?
Yep.
So, and we're in southeast Minnesota and just wondering, so some of these guys put a probe in and there's a good moisture profile as a whole, but maybe the top anywhere from 4 to 8 inches. And I think you kind of touched on this, but they're pretty dry. So if they put on 6/7 is that not going to show quite a bit, or that's not going to show a lot on the graph then, since a lot of that moisture is going to be absorbed in that top? I mean, if it's powder dry, I mean, especially 4 or 5 inches, because I've been having a lot of issues with guys not getting readings, and they expect to see something right away, and but there's plenty of moisture at 16 and 28. Does that make sense? Or
Yep. Yeah, I think you're hitting the nail on the head. You're seeing moisture being absorbed in that top X. So in that case, I would utilize the offset feature.
sure.
I was bringing up an example here. So we had, I'd have to go back and look at what the total rain event was here. I'll see what the auto recorded. What's today? Yeah, I'm not sure. I don't know. At least probably 3/4 of an inch here, we'll say. And the change in some graph was 736 to 780. That's closer to a 1/2 inch. Okay, so we had a total profile sum change of, we'll say 0.5 to 0.6 inches. Now look at where the infiltration occurred and how much of it hit 8 inches deep, which we can't see exactly because we got a 2 6/10 spacing.
Mm-hmm.
That 10-inch sensor is the red line.
Yeah.
Red line didn't move.
Right. Right. And it
So
barely
we
moved
had,
on the profile. So
yeah. And
well, not barely.
actually we can probably see how this is super low. I wasn't able to get this sensor all the way on the ground. This sensor is basically sticking out of the ground. So actually this 10 is probably closer to 8.
Sure.
Yeah, so we had probably 80% of the moisture, maybe 75% of the moisture absorbed by the first sensor, which was just basically at the surface, and then the remaining, what we had about 14% to 18.5, so 4.5% change at 6 inches. So yeah, I've been talking to guys about this over the phone. I mean, growers, and I talked to Nick Emanuel about this as well. Because of the situation that the main part of the corn belt is in, at least our area from about south central Nebraska east is in, with how dry things are. If you have growers putting on a 1/2 inch 1600s 70, the further you can push them to put more water on at a time, the better off they'll be. And what we've been seeing in the last 2 weeks is that whatever irrigation we've been applying is like poof, gone in the next 3 or 4 days, because it's not infiltrating deep. And I think we were losing so much of it to evaporation. We really needed to put on. I mean, somewhat, some grower somewhere would probably shoot me and say, "You're crazy." But I mean, what would happen if we put on 1.5 inches or 2 inches? And their first reaction a lot of times is going to be, "Well, I can't get around fast enough then." And that is definitely a factor to consider, is how much total time you can leave part of the field without having any water on it. However, for the long haul, if things don't change, you're better off infiltrating deeper and putting on more at a time, assuming that you're navigating around the factors that you have to deal with, like how long you can leave the crop on each pass, and you know, if you have topography issues where the pivots might get stuck, or topography issues where you might have runoff on heavier soils. You know, there's other factors to consider, but in general, it's a good idea right now to try and to increase those base rates.
One thing that we have to keep in mind is if we try to do that, our problem is that we'll end up we'll push water 36 inches within no time flat, just because we can't hold water. So if we try to put over an inch on, we're pushing water clear down to 24 to 30 inches, which is doing us no good there.
Yeah, texture would be definitely one of the other factors. I mean, there's probably some soils light enough that you got to be careful, but I think people will know when they are dealing with soils like that. If you're looking at a loamy sand or a sand, that's something to consider. And you're going to see that, though. I mean, you can kind of measure how far you can push the envelope by how deep you're infiltrating. You can see that on your sensors.
Thanks, Nick.
Yep. Somebody had posted, can you explain how the profile sum is calculated? We did that already. So basically you take your volumetric water content. So again, simple math here. If we have a 36-inch profile and we're reading exactly 50% volumetric water content on every single sensor, the sensor is saying half of your total profile is water. The other half is other stuff, but half of that total profile is water. In other words, how much total water do we have in our profile? So if every single sensor was reading exactly the same, and it was all reading 50%, we had 36 inches of profile. Half of 36 inches is 18 inches. That's how the sum graph is calculated. And so hopefully that helps again. Any clarification on that? Very good. Appreciate everybody joining. Appreciate the interaction, the examples. I think it's always good to see real world examples and when everybody can learn from each other. Continue to be patient with our support. We're definitely in a busy time of year as we get back to everybody. Try to give us details of the problem you're experiencing. We can try to best answer as quickly as possible. Thanks, everybody, and have a good rest of the day.